When we were younger, we used to think the air was clean if it looked clean. If the sky was blue, if we couldn't see smoke, if we could breathe without coughing, we assumed everything was fine. But for me, that illusion shattered the day I read that over 90% of the world's population breathes polluted air. And this pollution doesn't just stay in your lungs. It seeps into your brain. In fact, a rising climate temperature has been shown to worsen conditions like epilepsy, dementia, and stroke, and even increase risks for suicide and cognitive decline. During Europe's 2003 heatwave, 7% of excess deaths involved direct neurological causes. In the UK's 2022 heatwave, similar patterns were seen. Climate change is already rewiring our brains. That realization hit me hard, especially because I had spent years caring about climate issues from the outside in. I recycled, planted trees, avoided plastic, but I never asked what the environment was doing to me. So I began to wonder, what if we could see how pollution was affecting us at a molecular level? What if we didn't have to wait until we got sick to know that something was wrong? So I dove into publicly available data. I pulled greenhouse gas and pollution levels from the EPA. I used satellite records from NASA. And I matched that with RNA sequencing data. Hi, I'm Sanvi. And this summer, at Virginia Tech's Alexandria campus, along with Dr. Alterowitz, I explored a research project combining environmental data with gene expression to see how pollution might trigger the human body. I used a method called multi-omics, which means layering biology, like RNA data, with pollution exposure from specific regions. I looked at key genes like HMOX1, which protects the brain from oxidative stress, and IL-1, RL1, which is involved in inflammation. In high polluted areas, I saw these genes either overactivated or suppressed, basically misfiring. So I created something new, a carbon footprint index, or CFI. Most carbon indexes just say how much gas is released. Mine asks, what does this gas do to your biology? But with all the genes and pollutants, I needed help spotting patterns. That's where machine learning came in. I used models like Random Forest and XGBoost. The models learned to predict gene changes based on pollution levels, especially nitrogen dioxide, carbon dioxide, and PM2.5. Here's something wild. In zip codes with the highest nitrogen dioxide levels, the model picked up gene patterns linked to stress hormone regulation and memory loss. This wasn't just a might cause asthma situation. This was possible risk for depression, cognitive decline, and mental health disorders, all within the air we breathe. Now imagine a device where you can instantly see your unique CFI, based on pollution data of the area you're in and molecular pathway disruption. You'd see which brain-related genes are most at risk, and maybe even get recommendations for air purifiers or medical checkups. That's the tool I want to build, one that connects communities, especially low-income areas facing environmental injustice, to personalize health alerts based on the air around them. Because climate justice is about protecting our population's health along with the planet's. Here's a quick breakdown of what I actually did behind the scenes. I used pollution data from the EPA and NASA to measure nitrogen dioxide, carbon dioxide, and PM2.5 levels across the US. Then, I pulled RNA data, thousands of samples of brain, lung, and heart tissue that I could find. I focused on 92 genes related to asthma, cardiovascular disease, and brain function. I ran differential expression analysis to see how these genes were modified based on pollution exposure. Then, I trained a machine learning model to help predict these gene changes and further develop the AI. Finally, I used GC and KEGG pathway analysis to figure out what these genes actually control within the body. My most powerful finding? Genes like IL-1, RL1, HMOX1, and LTA4H, related to inflammation, were heavily dysregulated in areas with a heightened carbon emission. That means this isn't just some future scenario. This is already happening. Most health systems wait until people get sick to intervene. What if we didn't have to? What if we could predict disease just by reading the molecular fingerprints left behind by pollution? That's what I'm hoping the Carbon Footprint Index can be. A new kind of early warning system that can help predict based on your environment and your genes. And because I used only open source data and tools, this can scale anywhere, from cities to schools. Eventually, I want to partner with public health organizations and policymakers to design interventions that actually save lives, especially in at-risk communities. But for me, this wasn't just a project. This was a shift in how I see my role in the world. I started out trying to understand how pollution affects the population. Along the way, I learned how to research, how to collaborate with professionals and professors, and most importantly, how to believe that even as a student, I could still create something with real-world impact. It taught me that the boundary between student and changemaker only exists if you let it. All you need is curiosity, open data, and a refusal to believe that you have to wait until college to make an impact. We live in a time where AI models are trained in large data centers that produce massive amounts of carbon. But what if we flipped that around? What if we used this machine learning to survive the effects of climate change, not contribute to it? Because as the planet gets hotter, our brains and bodies get impacted. And if we lose the ability to think clearly, advocate, and innovate, what future are we even fighting for? So my message to students, researchers, policymakers, let's connect, let's collaborate, let's build tools that protect ourselves as well as the environment. Because the fight against climate change isn't just about saving the planet, it's about saving ourselves. Thank you.